G'day team, welcome back to another video, and today we're going to look at some applications of integration. And the first one's going to be the area between two functions. Now we've looked at integration and we know that the area under the function and the x-axis is the integral, but sometimes we don't want just that. We want this total area here between two functions, f of x and g of x. So our little rule for that is if f of x is greater than or equal to g of x for a less than or equal to x, which is less than or equal to b, where a and b are actually the intersection points of f and g, then the area between those functions is the integral from a to b of f of x take g of x dx, or we could you do it in terms of the upper function minus the lower function. And in this case, f of x is my upper function, g of x is my lower function over that domain. So you do need to be a bit careful of the order that you are doing your function subtraction. And we'll look at a couple of different examples now. So looking at this one here, we can see we've got this function in here, and this is my quadratic going on here. And we can see we want the area below the x-axis. Now this x-axis actually has an equation, it's y equals 0. So that's actually going to be my upper function. So my area is from 1 to 4, where the two functions intersect, of my equation. So actually, first of all, because y equals 0 is the upper function, I've got 0 minus, then I've got my function here. And we've got to be careful because we actually have to put that in brackets. Otherwise, we're not going to get the correct negation. Now, we know that this is going to be a definite integral which we can solve on our calculator. So I'll do a quick integration and then solve the fundamental theorem of calculus on my calculator just to save some time. So I'm going to pull that negative out the front. I'm going to get 1 on 12x cubed, take 3 on 4x squared, plus 5 on 4x. And we're going to solve that from 1 to 4. Now, you know how to do the fundamental theorem of calculus. So to save some time, this comes out as 9 on 4 units squared, okay? But you can see that big difference of that 0 take, all right? So you gotta be careful if it's under 0 minus the whole function. All right, example B, we can see we've got two very distinct functions here, a linear equation and a quadratic, and we want the area between them. Now, the intersection points are 2 and 5. So they create the limits of my integral. Now we've got to identify which function is on the top. If I can get my light. There we go. So this function here is on the top, y equals 2x take 5. Now that is the function we write first. So 2x minus 5. And I subtract all of my lower function, which is x squared take 5x plus 5. And I don't square that, I dx that. Okay, so again, let's just have a look at what this looks like simplified. So a equals the integral from 2 to 5. Now I've got negative x squared. I have 2x minus negative 5x, which is 7x. And then negative 5, take another 5, is negative 10 dx. And again, I'll do the part where we get to the fundamental theorem of calculus, and then I'll just use my calculator for the example and the answer. So I've got negative 1 on 3x cubed plus 7 on 2x squared take 10x. And that's going to be solved from 2 to 5, and that actually gives me 9 over 2 units squared. All right, so we can see how that works out. So I've put this part into my calculator. All right, one more example, and we can see that here the area swaps over. So I've got some area above the x-axis and some below. So when you see this, you actually have to split up the integral into two sections. So negative 2 to 1, and we use our upper function, which is my cubic here. So x cubed take 2x squared, take 5x plus 6, and I subtract 0 because that is the below function. So that there is just a normal integral. But then I add on the integral from 1 to 3 of 0 minus a cubic. Because 0 is now my upper function, it's that minus my cubic. So minus, in brackets, x cubed minus 2x squared minus 5x plus 6 dx. All right, now this one we're going to do by hand. So it's going to be a little bit of a process, but it is good to see how they do end up working. So this first integral, we know goes to 1 on 4x to the 4 minus 2, and we've got, we're not substituting in yet, are we? We're dividing by 3x cubed. Take 5 on 2x squared plus 6x. I'm going to solve that from negative 2 to 1. And then this negative, I'm going to bring out the front like we did above. And then we've got the integral that we're going to complete is 1 on 4x to the 4. And it's just a repeat of what we had before. So minus 2 on 3x cubed. Take 5 on 2x squared plus 6x. And we're going to integrate that from 3 to 1, or 1 to 3. Now, what you might be able to see ahead of time is when I actually put these into my function here, they will actually end up cancelling out, hopefully, but we'll see what happens. So when I put 1 in, I get 1 on 4 minus 2 on 3 minus 5 on 2 plus 6 minus, now negative 2 to the power of 4 is 16, divided by 4 is 4. Negative 2 to the power of 3 is negative 8, so that's negative 16 on 3. Negative 2 squared is 4, so that's going to be negative 10, and that's going to be minus 12. So that is my first part of that equation there. So I might just move them over a little bit. Then I've got minus, big bracket. I'm going to put 3 into this equation here. So 3 to the power of 4 is 81. And then 81 divided by 4 doesn't give me anything nice. So I'm going to leave it as 81 over 4. Minus 2 times 27, 54 on 3, which gives me 18. Minus 5 times 9 on 2. That gives me nothing nice, so 45 on 2, on 4. On 2. Yep, on 2, because of my 2 here. Plus 18 there for the 6 times 3. So that's a little bracket there, minus, and then we put 1 in there as well, which is a quarter, minus 2/3, and then we've got plus, minus 5 on 2, and plus 6, big bracket. All right, let's start having a look at what might be able to cancel. So the 18s there cancel out. We're actually going to end up with doubles of these guys and these guys because of this negative here. That's okay, we'll deal with that in a moment. So let's start dealing with some non-fractions first. That's how I like to approach it. So 1 on 4, take 2 on 3, take 5 on 2. I've got a plus 16 on 3. Then I've got 6, take 4, which is 2, plus 10, which is 12, plus 12, which is 24. Minus, big bracket, and I'll do the same over here. Now there's not many whole numbers there, so we'll just bring together everything. Minus a quarter, plus 2/3, plus 5 on 2, minus 6, just like that. Now, what I like to do is collect all the common denominators together. Said we're going to grind it out by hand. So 1 on 4, you can skip ahead if you like to get to the final answer. Minus 81 on 4, minus another 1 on 4. Then I'll do my on 3, so 16 on 3, minus 2 on 3. Then I'll do my on 2, so minus 5 on 2, minus 5 on 2. Okay, and then I've got my whole numbers, which is 24 minus negative 6, which is plus 30. All right, bringing these together, 1 take 81 is negative 80 on 4, and then another 1 is just negative 81 on 4. That should actually be a plus. Yep, that should be a plus from here. So that there's not quite right. I've got 2 on 4, take 81 on 4 is 79 on 4. Plus 14 on 3, negative 10 on 2 is negative 5, plus 30 is plus 25, and then we can get them all, bringing them together, 79 over 4, plus 14 over 3, plus 25, which is 593 on 12. Okay, so a lot of working out there. Obviously, in a test situation, you'd throw that into your calculator. But I thought it'd be fun to do some expanding. All right, thank you for watching, and we'll see you in the next video.